Okay, we're going to work through Unit 3 review for your response question B. I'd like you to do the same thing you did with free response question A for Unit 3, and that is look at the question, read through the question, attempt part A, all with the video paused, play the video, take a look at my solution for part A, see where you need help, see where you had questions, pause the video again, and work through B, C, and D in a similar manner. So let's get started on this. Consider the curve by the equation, the quantity 2y plus 1 to the third minus 24x equals negative 3. Show that dy dx is equal to 4 divided by the quantity 2y plus 1 squared. So several of you guys think of dy dx as y prime, which is okay. Just because the context of this question represents the dy dx, we're going to keep it that way. So we're going to take the original function, which is up here in the stem of the question, and I'm going to derive that original function with respect to x. And this is an implicit function because there's x's and y's together in the function. So the derivative of 2y plus 1 to the third would be 3 times the quantity 2y plus 1 to the second. And then with chain rule, we have to take the derivative of the inside. So the derivative of 2y plus 1 with respect to x would be 2 dy dx, or y prime. The derivative of 24x with respect to x is just 24. And the derivative of negative 3 is 0. Now we have to solve for this dy dx. So I'm going to first, going to simplify this here to be 6 times the quantity 2y plus 1 to the second dy dx equals 24. Okay, let's fix this here. Equals 24. There we go. Okay, so now I'm going to divide both sides by 6 times the quantity 2y plus 1 squared. 6 times the quantity 2y plus 1 squared. And notice I'm going to be left with dy dx is equal to, 6 goes in 24 4 times, 4 over the quantity 2y plus 1 to the second. And that is what they wanted us to end up with, and that is implicit differentiation, or deriving an implicit function. Part B. Write an equation for the line tangent to the curve at the point negative 1, negative 2. So pause the video and try to work through this by yourself. First thing we're going to need to do to write this equation is we're going to need the slope of the tangent line. So that would be by evaluating the derivative at this point, dy dx at negative 1, negative 2 would equal, I'm going to plug in that, let's see, I got to plug in, replace this y with the y coordinate, which is negative 2. So it'd be 2 times negative 2 plus 1, and that whole quantity squared. So 4 over, that would be negative 4, plus 1 is negative 3, squared is 9. So 4/9 is the slope, and I'm going to choose point slope form. So y minus the y coordinate is equal to the slope of the tangent line, x minus x coordinate. And we can leave it like that or simplify it a bit. Remember that the College Board does not recommend oversimplifying on the AP exams for losing, in case that you might lose a point for an algebraic mistake. Okay, moving on to part C. Evaluate d squared y with respect to x twice at the point negative 1, negative 2. So we want to find the second derivative and evaluate at that given point. So pause the video and attempt this part. So to start finding the second derivative, I am going to start with the first derivative, which is this. And you have a couple different ways to work through this one. You could use quotient rule. I am going to, instead of quotient rule, I am going to bring up the 2y plus 1, and instead of squared in the denominator, I'm going to write it as raised to the negative 2 power. So then the derivative of the left side, the derivative of the dy dx is d squared y dx squared, which is equivalent to, really guys, this is just the same as y double prime. Okay, and now the derivative of this side, well, the 4 is a constant multiple, so the 4 stays there. You bring down the negative 2. This quantity, 2y plus 1, and then that is raised to 1 less than negative 2 to the negative third. And then we're going to multiply it by the derivative of the inside with respect to x, which is 2 dy dx, or 2 times dy dx. Okay, so let's see if we can simplify it a little bit here. And yeah, you know what we can actually do here, because they give us a point to evaluate. Before even trying to simplify, why don't we try to evaluate that point? So the second derivative with respect to y, or respect to x twice, at the point -1, -2 is equal to 4 times -2, 2 times y, which is -2, plus 1 to the -3rd, times 2, and then times dy dx. Well, dy dx at this point, let's look at part B. dy dx at this point is 4/9. So we're going to substitute 4/9 in there. So let's see what we have here. We have 4 times -2, so -8. 2, -4 plus 1, -3 to the -3rd. And then times 8/9. So if we bring this 8/9 in front, -64/9. And then -3 to the -3rd, well, that's just 1 over -3 to the 3rd. So that should be -27. And it looks like this simplifies, let's see, negatives are going to cancel out, so we're going to have 64/9, so 180 and 63, 243? 64/243 for part C. Final part of the question, part C, or excuse me, part D. The point 16, 0 is on the curve. Find the value of the derivative of the inverse at 0. So I'm going to attack this one a little bit differently. I'm going to actually find the inverse function. So I'm going to switch the x and the y in the original problem. 24y equals -3. And then I'm going to find the derivative and then evaluate at 0. So let's take the derivative of this. That would be 3 times the quantity 2x plus 1 to the second. And then chain rows times the derivative of 2x plus 1 with respect to x. So that's 2. Minus the derivative of 24y with respect to x is 24, and then we can have a y prime or a dy dx. Let's just keep consistent with dy dx, and that equals 0. And we're supposed to find the value of the derivative. So if we want to solve for the derivative first, we're going to have 2 times 3 is 6, 2x plus 1 to the second equals 24 dy dx. Divide by 24 here and here. 2x plus 1 to the second over 4 is equal to dy dx. And I'm going to evaluate at 0. So 2 times 0 plus 1 squared over 4 is equal to the derivative at 0. Apologize, I'm syncing off the screen here, guys. Something like that. So I have 2 times 0 is 0, 1 squared would be 1, 1/4 is equal to the value of, the derivative of the inverse at 0, if I rewrite it in that form. And that is one technique. There's another technique where you use the equation to find the derivative of an inverse that we did towards the end of our meeting time in class together. I find this way to be a little bit more, made sense for me to work through. So thank you for following along.